Hi, it's Larry here of Xbox Live's Major Nelson, and welcome to the Xbox One Architecture panel. I'm pleased you could join us. I want to welcome all our invited members of the press here in the auditorium with us, as well as you watching at home on twitch.tv. Joining me, I've got some members of the Xbox One panel. Today, you're going to learn a little bit about the Xbox One software, hardware, services, and the architecture, and some of the decisions that have gone into making the system. Let's start with the introductions right here. Todd?
Yeah, my name is Todd Holmdahl. I run the Xbox hardware group. We're responsible for building all the consoles, Kinects, and accessories you see out there. We build everything from silicon to motherboards to mechanical parts. I've been working on the Xbox for 13 years, started in 1999.
So Todd has been with us since the very beginning of the Xbox. Thank you, Todd. Next name we have?
Hi, I'm Boyd Malterer. I run the software for the console. So think the operating system, the Kinect stack, the dash, anything that's not a game that runs on the box. I've been on the Xbox team for 13 years as well. And when I joined, I founded something called Xbox Live and ran engineering for that for 4 years, and then the developer program for 5 years. And since then, been working on media and now Xbox One.
Thank you. And then next to you, we have?
And I'm Nick Baker. I run the architecture and verification team in the Silicon organization. My team's responsible for picking all the cool technology that we put inside the chips. I have been doing game consoles, started in 1993 at 3DO. I've worked on Web TV, Ultimate TV, and all 3 iterations of Xbox.
And then, of course, if you're an Xbox gamer, you know who this next guy is.
I'm Dan Greenwald. I'm the creative director at Turn 10. We make Forza Motorsport. Like several of the people on the panel, I've been involved with Xbox through Microsoft Games for 13 years now. And Forza Motorsport's really about proving out what our hardware and services are capable of doing. That's what first party is.
There we go. Well, let's get right to it. I want to talk to you, Todd, and talk to you about how has this generation been different from the previous 2 generations of consoles that you've worked on?
Yeah, super good question. I think the biggest difference is what's going on in the living room today. It's different than what was going on 8 years ago. There are a number of major trends that are creating new forms of entertainment. The first, of course, is the internet. The internet is in the living room in full force now. People are not only gaming, but they're streaming video, they're downloading apps from the internet, they're playing interactivity on their television set, they're even browsing. It's really creating a whole new way to watch TV and interact with your television set. The second thing that's much different is that there are multiple devices in the living room that are complementing what's going on the TV. You see PCs in the living room, you see tablets, you see phones. And then the third thing that is different is NUI. We started Natural User Interface in 2010 with Kinect. You're starting to see more and more voice and gesture in the living room, and that is also creating a new form of a new way to interact with your television set. Now, what we had to do, we had to not only build a great box for gaming, but we also wanted to make sure that we had a box that allowed developers to take advantage of all these things that were happening in the living room.
Now, Dan, you've got some comments how things have changed over the years from a creator standpoint.
Well, Todd's absolutely right. It's just a different world now that we live in. Gamers are more connected with each other. Devices are interconnected. One thing I'd really like to comment on is this is a more powerful box, which is fantastic. But it's not just that it's more powerful. It's also connected. It's connected to the cloud. And that gives us as creators the ability to offload some of the processing that we would use, that we would do on this really powerful box, but also do processing that we can't do even on this powerful box because we have the power of the cloud. So we can move things, physics, AI, worlds. We can move incredible rendering capabilities to the cloud. And that means this box is going to evolve. So this is a radically different way of thinking about how we work as creators on a box.
Now, Todd, you brought up those 3 elements a moment earlier. What are some of the challenges about integrating those 3 things into the Xbox One architecture? And can you talk about some of those technical challenges?
Yeah, first, we wanted to build a really powerful box. We build a custom system on a chip for this with a CPU and a GPU. We have embedded SRAM on die on our chip. We really like that because it gives us high bandwidth to the GPU to keep the GPU fed with data. Sometimes when you go off chip with memory, it's harder to keep that GPU filled with data. The second thing is we made the box so that it could be instantaneous and simultaneously switch from one app to another app. We worked with Boyd's team on the software. We added lots of memory, both system memory and flash cache, in order to have that simultaneous and instantaneous action out there. The other thing we did, and you heard about this, is we wanted to be connected and ready. We added Gigabit Ethernet to the box, so you had high bandwidth to the internet. We added 802.11n radios, a couple of them in there, so that you could be connected wirelessly to the internet as well to other devices in the living room, so that you could have these great multi-device experiences using smart glass apps. And then for the ready part of it, we really architected the box at the beginning to have multiple power states, so that you could use just enough power for the experience that you were in and not anymore. And if you were transitioning to another state, you could do that easily and quickly. And the best example of that, of course, is Wake on Voice. We have just a little bit of power in Kinect and a little bit of power in the console to process the voice that's coming in. And then when you say Xbox on, we immediately can power on quickly and get you to your experience. The last thing is we went all in on Kinect, completely redesigned it from the ground up, this new time-of-flight technology. It's going to give you better identification, better field of view, better depth. The audio, voice is better, identification. We've got HD in there. Just completely redesigned the whole Kinect sensor.
Now, Nick, I want to talk to you about silicon because that's your department. Tell us about some of the things that came from your team and some of the challenges you came across designing for Xbox One architecture.
Yeah, so if you look at everything we're trying to do with saving power consumption, running multiple operating systems at the same time, delivering the performance you want to do, the feature, the groundbreaking technology in the new Kinect sensor, it really is not possible to do that with off-the-shelf silicon. So it was pretty obvious early on that we needed to develop custom silicon for this and really develop a lot of those things from the ground up. Turned out we had to develop 5 pieces of silicon split between the console and the new Kinect. And they're not just individual pieces of silicon. We need to make them work in a coherent fashion even across USB in certain cases. So we had to verify all these things together. It involves getting the latest simulation, emulation tools. We bought this piece of technology that lets us run as fast as possible before we get any chips back. It's a piece of equipment that actually takes 50,000 watts and is water cooled, has a water cooling tower outside. We were able to run 10 trillion cycles in simulation before we even got the silicon back in the lab. So it gives you a sense as to what we had to go through here.
So you're from our Silicon Valley campus. You're doing an enormous amount of testing on the actual silicon.
Yeah.
Todd, you mentioned a moment ago about the Xbox One Kinect sensor. Can we kind of pull that apart a little bit and tell us about what are some of the enhancements there?
Sure. The new Kinect, again, completely redesigned from the ground up with this time-of-flight technology. First of all, field of view is about 60% better than what we had in the last generation. This allows us to fit 6 skeletons in the sensor as opposed to 2. This allows somebody tall like me to get 3 or 4 feet closer without getting my head chopped off by the sensor. It allows the sensor to be used in smaller rooms because now people can get closer and still be in frame. Another thing that we did was we helped the depth quality quite a bit. Our minimum object size is about 2.5 times better. It allows us to create better skeletons, and you saw some of this when Mark was presenting. We can see fingers and hands better. We can use those in our experiences more now than we could in the past. And then the last thing that is different on this design that we didn't have at all in the last generation is we have what's called active IR. With the time of flight sensor, you get a really good IR image, and you can use that's particularly good in low light situation. But what it does is it helps with identification and allows us to really make sure when you walk in, it gets you right, 100% of the time. It knows who you are, and that IR helps a lot in the low light where you have the illumination. It also helps with things like expressions, like you can tell what's your face, whether you're smiling or you're neutral. It can tell whether or not you're engaged. And we can add that into the overall toolkit that the developers can use.
So it's really collecting a much more accurate data than we were with the current generation.
More accurate data, more data, wider field of view, all of the above.
Now, Boyd, I want to get to you a little bit because we heard a lot about the software and this instant switching, and your team has worked on that. But I want to ask you about what are some of the challenges that you're seeing with current generation gamers, and how are we addressing that with Xbox One?
Yeah, good question. When we set about trying to design the operating system for Xbox One, we start with the normal thing. Okay, it's going to be a more powerful box. We want it to be great at playing games. But I believe that we have to look at who our customers are and who are the people who are playing games and understand them in order to know that you're building the right thing for them. So you look at the next generation gamers, and you realize that their behavior and their world is fundamentally changed from the last generation. In the last generation, smartphones hadn't really hit, tablets hadn't hit, laptops were around, but they weren't as ubiquitous as they are now. And when you look at people who are watching media today, especially younger people, and you realize they're watching a movie, they're texting with their friends, they're communicating over various applications and services. It's a very dynamic world, right? They're connected with lots of services, and things are always changing. And we realized we had a real problem, right? The normal playbook would be to put a very small, dedicated operating system down on more advanced hardware and then go. But if we did that, especially given the needs of the new gamer, we'd realized that just putting a new OS, dedicated OS down on newer hardware would be building a shiny version of last gen. Right? So we really wanted to appeal to the needs of the next generation, and we realized, okay, we've got to support the dynamic world of apps and services and change and everything that the internet and the startup culture has brought. And at the same time, we still have to meet the needs of the next generation game developer. Now, the game developer has kind of the opposite needs. The game developer doesn't want change. They don't want apps coming and going. They want to know exactly how much RAM they have, exactly how much CPU, exactly how much GPU, so that they can tune the assets that they're putting into those games.
And I'm looking at Dan for that, because that's what he does.
I mean, these things are expensive. Games are really expensive to build. And you have to tune the artwork. You don't want to build 20 versions of the art because you don't know what GPU or CPU you're on. You want to build just the exact right artwork. Now, if apps and services and other things from other developers are coming and going on the box, that means you're in a dynamic environment, and you don't have guarantees as to exactly how much resources the game developer is getting. So we sat back and went, oh, geez, this is a real problem. And we decided to take a risk, and we went and chose technology that originally came from the services world. So think virtual machines. We started with Hyper-V from services, and you start stripping out all the general purpose goo. Right? So in normal virtual machine technology, you don't know exactly what apps you're running, what OS is. But in this case, we know exactly which. We know there's two. We know there's one about apps. We know there's one about games. We know exactly how they're going to be configured. So you strip all the general purpose stuff out. You boil it down to the bare minimum, and you get it really fast on both. So that's what that middle OS was, right? Think virtual machines, stripped down to the point where they're just partitions, guarantee resources to the two different sides. But now we can have one operating system which is general purpose, which is made for apps. It's made to be flexible. It's made to allow third parties to stick things on. And here, a real difference from consoles in the past, that operating system boots and is created when you turn the box on, and it stays booted and it stays running the entire time the box is on. Now, normally in last-gen consoles, when you put a new game in, you reboot the box. Right? So there's only ever one app running at a time. So now we have a world where we've got one partition, which is aimed at games, all about lots of memory, lots of CPU, lots of GPU, very predictable, and it is one game at a time. And next to it is another VM with lots of apps that are running for a very long period of time. This way, you're able to get those matchmaking sessions that are running and looking for the right players while you're watching a movie or while you're playing a game or doing all kinds of things in the other VM. You can do two things at the same time, and this really solves a lot of problems that we've had in previous generations. For example, matchmaking was always kind of hard. How do you know when your friends are going to be online exactly? What do you do while you're waiting? Okay, well now we can have, you're playing a game, you're watching a movie, you're watching a show, that matchmaking session's going on. Another thing that we learned in 360 was, as much as we try to keep up in the startup world, it always runs faster than us. And we updated 360 lots of times and kept it fresh, but we aren't always going to predict what the next big social service is going to be, or what the next trend is going to be. So this time, we want to invite them to come and build their apps on our platform and have it work with all the games that have ever been built on it and the new ones that are going to be built and keep them in harmony. Now, the last piece I'll mention is that with Xbox Live, when Mark was talking about the number of machines that are being added, this is a big deal. Right? Next gen isn't just about having lots of transistors local. It's also about having transistors in the cloud. And the best way I can explain it is that, to me, next gen is about change. I've got these games that stay the same. I've got apps that are changing. But now, you start throwing in servers that are just one hop away. And I can start doing things like, you look at a game, and there's latency-sensitive load, and there's latency-insensitive loads. Let's start moving those insensitive loads off to the cloud, freeing up local resources. And effectively, over time, your box gets more and more powerful. This is completely unlike previous generations. You've got a fixed number of transistors in your house and a variable number of transistors in the cloud. And as we get smarter about which loads we can move into the cloud, that frees up local resources to do things that are about the here and now. And this is really exciting. I think that's really cool.
One thing I want to point out is that you also talked about those two operating systems that are sitting next to each other, and then you've got a third one which enables you to swap between them instantly. Can you tell us a little bit about that?
Yeah, the swapping. I mean, both of these are running at the same time, right? The Snapped app, the game, the TV, a game, whatever. Right? Those things are literally running at the same time, and they're both drawing at the same time. Now, at the hardware level in the GPU, we've got display planes, right? And we can just swap which one's on top. Right? It's instant because they're both going, and you're just choosing which one are you going to show on the screen. So there isn't a whole lot of work to, okay, now we've got to tear something down and bring something up. They're both going, and it is literally, bam, you're into one, bam, you're into the other one. And that's why it's so fast. And having these two different virtual environments running and that ability to switch between them is what gives it that instant feel.
You obviously we had a blank slate when we were starting to design this generation. I want to talk to the panel here, each one of you, your input into it, and Boyd, did you go to the hardware team first? Hardware team, did you go to Boyd first? Dan, did you come over here and say, hey, this is what I want? Or tell us a little bit about that process as much as you can.
Yeah, we did have a blank slate, and where we started, where we always do, is with the customer. What are some of the experiences that we want to offer to the customer? What do we want to do for gaming? What do we want to do for entertainment? There were a number of trends that we loved. There's a number of things that are going on in the hardware space that we love. We worked really closely with Boyd and Dan. One of the beauties about being at Microsoft, you have your hardware, your software, and your experiences all under one roof in order to bring all these things together so you can talk amongst yourself. So we got some really good customer requirements. We really understood what was going on in the living room and the trends that were out there. We had some great ideas on some technology, and I think Kinect represents that. The cloud represents that. Smart Glass represents that. The OS stuff that Boyd was talking about represents that. And a few years ago, we just started putting those things together, really kind of converging on different ideas. And developing these things just takes a while. You prototype something, it doesn't work, and then you go back. But we were able to converge on a product that we love. We think that it's a product that's really going to resonate well in the living room and allow people to not only have this great gaming experience, but these great entertainment experiences. And the whole ecosystem is going to continue to grow as we go forward. Now, this will just be the start. We have a lot of power that's built into the box for years to come.
And then, Boyd, you obviously took that blueprint and you started designing the architecture of the system.
I can think of at least, there's lots of examples. So I can think of at least two specific examples. The first one is on 8 gigs of RAM. Why 8 gigs of RAM? When you think about games and how they work, 5 was probably going to be good enough, or 4 might have been good enough, but we really wanted to have those two things running side by side. right? And that meant we had to have the 8 gigs of RAM. Conversation between hardware, that's money you have to spend on these boxes, but it was really valuable to have this fast switching and having the things running at the same time. So that became a good conversation.
You want to be power efficient as well and be able to
Exactly.
put it in the living room and acoustics and everything.
The other example is when I think about the graphics stack in particular, memory bandwidth is really important. And we've got these ESRAM caches on the chip. It's really, really fast caches on the chip. This next generation of GPU it is kind of a break from the last generation of GPUs, which were very microcode optimization sensitive. The exact order of the codes and the shaders made a huge difference in how fast they ran. This time, the chip architecture is based on supercomputer-like technologies, and it's much more about data flow. Having the right data in the right caches in the right places at the right time is what will make all the difference in the world for taking advantage of these chips. It's relatively easy to get your code ported onto it. It's relatively hard to get it optimized and really, really looking good. And we worked really closely with Nick's team to make sure we had really good caches on the die, ready to feed the GPU, and that was a really important partnership.
Yeah, and I mean, our process goes back actually many years in terms of understanding where things, where developers want to take, where creators want to take content, how working and understanding what the concept of snap and instant switching, and you go back and try to canvass the technology industry and see what is it that we need to do to bring that into the living room. And sort of been mentioned before, we just want to point out that a lot of the technologies we had to go and investigate on the hardware really belong in a data center. We talked about Hyper-V and Remote FX. I mean, we're distant cousins of that, but the same underlying tech has to work in the hardware. And so we're 64-bit processors. We need to support hardware virtualization to be able to have multiple operating systems. We had to invest a lot in coherency throughout the chip. So there's been I/O coherency for a while, but we really wanted to get the software out of the mode of managing caches, and put in hardware coherency for the first time on a mass scale in the living room on a GPU. And nested page tables, very technical term, but these are not things that if you look at across CPU, GPU, I/O, and making all that stuff work and bringing it into the living room, this is really a first in terms of making.
And Nick's reminding me, I mean, this stuff's hard to do, right? And one of the advantages that we've had is, well, frankly, it's being at Microsoft, we've got a lot of resources outside of our immediate group that we were able to take advantage of. There's Microsoft Research, which has helped tremendously on Kinect, but we've also been able to take advantage of software like Hyper-V and really talented engineers. For example, David Cutler came onto our team about a year and a half ago, and he has been himself building that hypervisor that does the switching back and forth. I remember there was some press. What is David Cutler's moving to Xbox? That's interesting. And I mean, this guy invented operating systems, right? He goes way back. We're super lucky to be able to work with people of that depth and talent, and it's made this kind of project possible.
I think partnership is really the key, not just who we have, but how this company is able to bring all the different groups together like Microsoft Research. And it's been going on for a while. I mean, honestly, this living room it started changing a while ago. And as you said, we've been playing catch up and staying on the forefront on the console world and in the living room. And this is the next giant leap forward in bringing that living room to the current age. What's exciting to me is how it does bring everything together. And we got together several years ago and started thinking about this and bringing different teams together with different takes, including bringing game teams together, but also how we manage entertainment as creators. Now, we're obviously part of game teams, but it's important to have a really good tool belt. And that includes things like Kinect, that includes Smart Glass, that includes now this world where we can snap apps into place and actually have an app. If you think about a Call of Duty Elite, you think about a Halo Waypoint, being able to manage your kind of meta career while playing in a game, now you can do that on one screen, or you can do it on the screen in your pocket while you're playing. This console really brings that to bear, and that's what's so exciting to me.
Yeah. I just want to talk a little bit about some of the, we talked about parallelism at a operating system level, but even to get all of this processing out of the box in the first place. You know, that we had to really think about how efficient we are in all the parts within the silicon. So Xbox 360, love it. In-order CPU though, not that efficient. You look at the GPU, it's vector processor, which is great, but it's a little bit brute force. It doesn't use all of the hardware every single possible cycle. So we went through and reanalyzed that. We have latest out-of-order CPU technology. Each CPU core is capable of doing 6 operations per cycle. So across the 8 cores, that's 48 operations.
And there's many cycles per second.
Billions, yeah.
Okay, just to be clear.
Just to be clear. The GPU as well is multitasking, so you can run several rendering and compute threads, so all of the cloud effects and AI and collision detection on the GPU in parallel while you're doing the rendering. And switch to a scalar engine, which actually means that a lot of the GPU is being utilized. The GPU can do 768 operations per cycle. And again, on the RAM, we talked about that, but really wanted to get 8 gigabytes and make that power friendly as well, which is a challenge to get both power friendly for acoustics and get high capacity and high bandwidth. So with our memory architecture, we're actually achieving all of that, and we're getting over 200 gigabytes a second across the memory subsystem.
I know that's really important to me, drive an electric car, worry about that kind of thing, and knowing that this is a box that's able to change its power consumption based on the loads that are going, I feel really good about that. Sometimes, if it needs it, the power's there. If it doesn't need it, it'll go into a lower power mode and use only what it needs to.
Yeah, we took a lot of new technologies. Each piece of the system is able to switch. Within the silicon, there are actually power switches on the silicon. They actually shut cores off which are not being used. We can apply dynamic frequency voltage scaling, so if you don't need to burn the power, you don't have to burn the power.
So this chip is actually scaling up, like Todd was saying earlier, scaling up and down accordingly. Nick, I want to talk to you a little bit about the living room. Putting a piece of silicon in the living room in this beautiful console. What are some of the challenges for designing for the living room?
I think power what is probably the biggest one, just acoustics, just making sure that we're relevant for the current age there. But there's a lot of new standards, hooking up to TVs and your companion devices. So we adopted 802.11, ABGN. We have multiple radios, simultaneous 2.4 and 5 gigahertz. USB 3, multiple ports on the box. To do some of the live TV scenarios, we needed HDMI in, and that's another thing we had to go and develop on the silicon. So we have an HDMI in solution. Both HDMI in and HDMI out are the latest standards. We support 4K, both on the input and output, 3D, stereo 7.1 surround. And so, just making sure we were up to date on all of that stuff as well. And consumer electronics control as well, so you can do the turn on your TV and stereo equipment as well.
How is it for you guys as creators and software and hardware designers to look into the future? And is it a challenge to work together and say, this is where we think the future is going, we're making that bet?
Well, I think it's a challenge, but it's exciting. I mean, honestly, all of us have worked here quite a long time, and even as Don said, opening up the whole discussion, this is honestly one of the most exciting times in my career because of what we have to play with as creators. Kinect, being able to read heartbeat sensors, being able to, in essence, be biometric. What can you do with a game that way if you can actually turn the tables and, see if the player's lying, see if the player's excited, see if the player's scared. There are incredible places this can go. And as Boyd said, having an optimized, predictable platform allows creators freedom because we know the rules. It's like playing chess. You need to know the rules. If you know the rules, you can do incredible movements. Too much freedom actually paralyzes you. So what we need is incredible power with a very stable rule set we can optimize against. And then really easy to use tools, such as Kinect, such as Smart Glass, where it's just baked in and we can start combining things that people never expected. So bringing Smart Glass and interacting between Smart Glass and Kinect, plus having this beautifully rendered screen. I mean, honestly, the sky's the limits of where we can go. But what excites me the most, as I mentioned earlier, was the cloud. And that is, in essence, giving us the freedom that's kind of fear-inducing, in that we don't want the randomization of too much freedom, like having to control your PC config. As a developer, trying to control for PC config can be a lot of work. But now what we get is the power we can tap directly into to offload processes and do, again, the low latency processing we want to put out there. So now we have the best of both worlds. We have a very stable platform that we can create from, and we have an ever-evolving and more powerful world that we can tap into.
I think that really is a fundamental difference between this generation and the last generation. You know, the last one, that box was fixed, and the game was all about optimize, optimize, optimize. You know, the games that we see now on 360 look tremendously better than the games that launch on 360 because we deeply understand that chip. That's going to happen in this generation, but add to it a growing number of transistors in the cloud that are really not very far away that you can start to move those loads onto. You can start to have bigger worlds, you can start to have lots of players together, but you can also maybe take some of the things that are normally done locally, push them out. And you know, this generation is about embracing change and growth while still maintaining the predictability the game developer needs. Right? This is a balancing act that we have to achieve. And I think we're going to pull it off. This is very exciting. This is a new way of thinking about gaming consoles and what could be done with them.
Yeah, I should also say.
No, I think that there are a number of inflection points that are really critical for experience development going forward. The inflection point of the internet and the cloud, and these guys talked about it, it is going to change the way people experience things in the living room and any place that they carry a device. There's an inflection point occurring with the multiple devices being connected together and having an ecosystem connecting all things together. And then there is an inflection point with natural user interface. When you get these types of inflection points occurring, there's opportunities to create these incredible products, and there's an opportunity to shift share from one set of devices to another set of devices. I think we're entering that era right now, and if you've ever been developing products, you know, these are the types of things that you look for. You get up early in the morning and start figuring out how you're going to apply that to the product, how you're going to work with your research group, your experience group, your software group, and your hardware group, and making something that resonates with the customer.
Yeah. Nick, did you have something to add?
Well, it's something that Boyd triggered about, and that about infinite worlds. There's also some technology we put in to enable really large dynamic worlds as well. So we have a single partially resident textures that the GPU supports, which essentially means that you can save potentially gigabytes of memory in not having to have all of the data loaded at all of the time. And so the GPU itself can figure out if something's actually in memory or not. It doesn't need everything to be physically in memory the whole time. And we also put in compression as well. We have LZ77 move engines that can just work behind the scene and compress and decompress, which is going to be really super important for working with data from the cloud.
You know, one more area, I want to touch on one more area of growth and also kind of working with the hardware team. When I think about the Kinect stack, the software stack on Kinect isn't one of those things that is necessarily fixed. Right? There's a huge bank of machines that are running machine learning algorithms that create the software that takes the images from the depth camera and turns that into skeletons and things the games can actually use. And we've had a really good partnership with the hardware team on what's the right camera and the right technology to go into it. But there's still a huge bank of machines doing this machine learning and constantly gathering. We're constantly gathering new information from the team and from how it works and building better and better algorithms. So I expect that to also improve over time. Right? It's, again, growth. This is not going to be as static a platform as we've seen in the past. And both in the OS, from Kinect, from overall functionality, it's going to be fun.
And even your games won't be as static. It was mentioned quickly in the briefing, but achievements, things that are actually evolving over time, and games that can evolve over time based on what we're seeing. So again, doing processing in the cloud allows us to have a window into how the world is moving. What are people doing? So we can be direct and design evolving worlds. If you imagine a giant epic world where my actions interact with yours, that's one level, and that's very cool. But another one is just kind of taking the meta level, where everybody is doing a lot of things, and we see that movement and can re-put that into the game automatically. So the game actually evolves over time. Achievements evolve over time as we realize that taking an arrow in the knee actually becomes something that people want to achieve. that can actually be an achievement that just comes right into the world.
Really good point. When we first built Xbox Live, we wanted to add a persistent nature to gaming, right? So it was an online service. It supplies persistence to games, and games ship on a disk, and they ran in the original Xbox. On 360, we added achievement points. It got better. It got bigger. But now, when the game ships on that disk, it's not static, right? The game developer can choose, hey, people are playing this game slightly differently than I thought they would, so maybe we should add some achievements over here, and you can do it after the fact and change the game without necessarily perturbing that local world of the optimized graphics and the optimized gameplay locally, but still adding new achievements, adding new challenges, having growth because it's connected to the cloud, going through these apps that are over on the dynamic side of the operating system. It's all going to work together.
And all that, plus, you get the things you expect. So the thing we've actually kind of glossed over is the fact that this box is just very powerful. So we can do things in physics, we can do things in animation, we can do things that we've never been able to do before, and it takes up a smaller footprint. It's incredible, right?
Now, we saw some of your game a little bit earlier in the show, and we're going to see hopefully some more stuff at E3.
I would expect something like that.
Okay.
Yeah.
Well, that's only 19 days away. Boyd, we've only got a few more minutes here. Before we wrap things up, I just want to talk to you a little bit. Actually, Todd, both of you and Boyd, you guys are here from the beginning. Looking back, we all talk about putting putting the network port in the back of the original Xbox. That seems so ridiculous now, right? But looking forward, are we at that point now where it seems obvious that this console about it being, talking to the transistors in the cloud like you spoke of?
For each of these generations, I think there's been at least one major innovation, one major change that's happened. In the original Xbox, it was putting that Ethernet port on. That was a really big deal. We had a powerful box, but just embracing the fact that there was a cloud and the internet was there and trying to figure out what to do with it, that was pretty radical. On 360, I would say it was HD, right? That was a whole new thing. Obviously a major change in graphics processing and the way architectures. And then the way it interacted with the cloud was significantly better. So there was definitely change there. For me, this time around, it's about embracing ongoing change. This is really fundamentally different. It's a different way of thinking about your architecture, a different way of building your architecture, and expecting it to grow and change over time. We could also go on about how the supercomputing style architecture makes some change. So there's going to be different ways you build your games. But to me, the really big fundamental disruption is the fact that we can't expect these boxes to be static. They don't live in a static world. Lots of apps are coming and going. Lots of services are coming and going. We have to embrace the internet, admit it's there, let's participate in it, while still having the great games with their predictable environment. Really tough balancing act to pull off.
The other thing that I will add is the decision to put Kinect in the box in every box was a big decision for us. And I think, like back in the days of putting the Ethernet port on the back, that the developer always knew that they were going to have an internet connection. Now a developer is always going to know that they're going to have Kinect available. They know they're going to get great identification. They know that they're going to get great skeletons. They know that they're going to get voice and voice recognition and voice conversation in a great way. They know all of these things, and now that they can start adding these into their games or their experiences. I think that you're going to see some great experiences start out when we launch, but people are going to learn more and more about the power of Kinect and what it can do with the rest of the box, and you're going to continue to see those experiences even develop further.
And I'll actually go to you on that, Dan. Kinect to you as a creator, we saw a little bit of it in some of your previous games. It certainly opens up a wide palette of possibilities moving forward.
Absolutely. Something I mentioned is being Forza Motorsport and Turn 10 being part of first party means we do have to partner tightly with them, with all the other teams, and figure out how to showcase this great technology that's going into place. And that's what's really exciting. And just to go back for a second before I actually go forward into Kinect, with the original Xbox and the Ethernet connection and Xbox Live, that was a big deal. And so we embraced this idea of Web 2.0, which was ahead of its time. It's obviously a long time ago. Web 2.0 is not really talked about anymore. But putting user-generated content and painting people's cars and trading between different people. That was a way of showcasing this incredible power, plus having a hard drive in the box, which is another thing that was very new in the original Xbox, and having these incredible painted liveries. So in Forza Motorsport 4, we looked at Kinect, and it was this new boon. We could do Kinect driving, we could do moving around the car and exploring the car. And that was actually an incredibly ahead of its time sensor, and yet nothing next to what we have right now. I mean, getting incredible dexterity within the hands, seeing that, as Todd mentioned, getting closer in smaller living rooms, going farther away, the voice recognition, and then just working in the dark, working with children, working all the time, all the things that, even though Kinect 1 was the most, honestly, it was an incredible technical achievement, it had its limitations, and those are addressed and then some. So now we're actually freed up not just to cover over, oh, my kids get cut off, or I'm really tall and I'm not seen there. But going into, wow, the player is actually getting excited. We can see that they're flushing, they're getting agitated because they're playing online, or we can see, what's actually happening in the room, that somebody has come in behind them. They maybe don't know about them. How can we do this into a horror game? There's so many different ways we can now use all of this information that's being brought into the box.
I don't want a backseat driver in Forza.
And it's free.
I don't want that.
A ghost backseat.
You get plenty of that already.
The nice thing is it's basically free to us as creators.
Yeah.
It's simply part of the box. It's simply part of the tool set. So when you pick up that tool belt, there it is. There's the hammer.
There it is. All right, well, we only have a few more minutes left, gentlemen, so I'm just going to ask for each one of you for maybe some closing thoughts before we wrap it up.
Well, this has been, of all the generations I've had an opportunity to work on, this has definitely been the most exciting for me personally. I think we're doing some things where we're integrating with hardware, software, services, and experiences like we've never done before. We have an opportunity to really change the way people interact in the living room with this product. And I really like the fact that this is just the start. We're going to come out with the product. There is a lot of opportunity for us to continue to develop experiences with the cloud, with the power that we have in the box, with the power that we have to connect to other devices. And I see great experiences already, and I know that developers and people developing experiences are going to take that power and even develop more exciting things as we go forward.
What?
Yeah, for me, the question I obsess about is, what is next gen? I love games. I've been playing them for a long time. I don't know if I call myself a next gen gamer, because the idea of tweeting and being social while playing a game just kind of drives me crazy. But I watch my nieces, I watch other people who are younger who play games, and I see the way they interact with movies and their friends and all that stuff at the same time. And I want to build a box that's modern, appeals to them, and still meets my needs as a gamer. At the same time, the rest of the entertainment industry is also changing around us, and the TV thing is very exciting. There's lots more in there that we haven't talked about yet that you'll see. And it's just embracing that change, understanding that the next generation is not a static device. That's what it's about to me.
Yeah. Nick?
All I can say is I just can't wait to get one.
That too.
Yeah, it's, just as, playing games, entertainment, it's been a thrill working on it, and I'm sure it's going to be excellent once it's in the living room.
Yeah, absolutely. And then finally, Dan, you've got a lot to share.
Well, I'm just very excited about this generation. As I mentioned, that this is the most exciting time of my career because there's so many innovations coming our way that we can, as creators, take advantage of. And more importantly, I think this is the first living room device that is embracing this huge cultural change where people expect and in all of their products. They expect their phone to be a computer. They expect their computer to be a tablet. They expect their tablet to be an MP3 player. I mean, everything is supposed to work together. Cars now have internet connections, which is fantastic. I've got an app in my car, multiple apps. That's what people expect, and that's what they demand of their living room.
Yeah.
And so that's really challenging for the four of us and those that we represent, but incredibly exciting, not only for the consumer, but for the four of us and all that we represent. How can we challenge this? How can we bring people the entertainment that's not just, wow, that would be cool, but actually, that's what I expect. That's what I demand. Our hope is that 1 year, 2 years, 3 years from now, everything that we're doing right now is simply expected of all devices, and probably my car.
Right.
Okay, shouldn't play Forza while driving a car.
That would be weird.
It's
But,
a little meta, but anyway.
Yeah.
Well, listen, I want to thank everybody here in the audience, as well as watching on Twitch TV at home. Don't forget, 19 days from now, we'll be down at E3 in Los Angeles. We'll have live coverage of everything going on there. More Xbox One games. We're looking forward to sharing even more details with you. So thank you very much. Have a nice day. Thanks, guys.
More cardio?